Hello everyone, my name is Amber Sargent and I will be going over the decimals portion of chapter 17, which includes decimals and percentages. So let's get going. Learning objectives for decimals. After this lesson, students will be able to describe how the place value system links to the understanding of decimal fractions, explain the role of decimal points, and explain how percents are related to fractions and as well as decimals. What are decimals? Decimals are fractions whose denominator is a power of 10 and whose numerator is expressed by figures placed to the right of a decimal point. Why do we need these silly little points or dots in the middle of our numbers? We need to be able to interpret decimals in order to do certain things such as read precise measurements, determining different outputs when we use calculators, or even understanding different statistics such as at the Olympics. I'm pretty sure a lot of you guys like to watch basketball, football, tennis, soccer. It makes it a lot easier if you understand how to use decimals. Jobs that actually require decimals. So you want to pay close attention if you are interested in any of these careers listed. So nurses need to know how to use decimals, pharmacists, engineers, and even chefs. I like to cook myself, so I know the importance of decimals when it comes to cooking. You want to make sure you have the right measurements so that your recipes come out correctly. Decimal place value. So let's check out this video so we have a better understanding as to what decimal place value actually is.
Hi, I'm Rob. Welcome to Math Antics. In this video, we're going to learn about decimal place value. As that name suggests, it's related to regular place value. So be sure to watch our video about that if you haven't already. In that previous video, we learned how to count using just 10 different digits and number places that represent different size groups. For example, if we needed to count 235 apples, we use different number places for counting by ones, by groups of 10, and by groups of 100. The digit 2 in the hundreds place represents 2 hundreds. The 3 in the tens place represents 3 tens, or 30. And the 5 in the ones place represents 5 ones, or just 5. It's a pretty amazing system if you think about it. It only has 10 digits, but those digits can be reused in different combinations to count any number from 0 all the way to trillions of apples and beyond. But, as amazing as it is, there's just one little problem with our number system so far. What if you don't have a whole apple? In the place value video, we only learned how to count whole amounts, or what we call whole numbers, which is the set of numbers you get if you start with 0 and then count by ones, 1, 2, 3, 4, and so on. But there are things besides whole amounts. It's possible to have just part of something, like just part of an apple. And that means there are in-between amounts. You might have 1 apple or 2 apples, but you could also have something in between that, like 1.5 apples. How can the base 10 number system handle situations like that? The answer is decimal places. Decimal places are a way of extending the base 10 number system so that it can represent amounts that are in between whole amounts. Decimal places are just like regular number places, except that instead of using them to count groups, we use them to count parts or fractions of things. To see how the base 10 system is extended with decimal places, let's look at the pattern of number places that we saw in the last video. We started out with a number place for counting things one at a time, and when we hit the limit of counting with it, we used another number place on the left side of it for counting groups of 10. By combining those two number places, we could count from 0 all the way up to 99. But when we needed to count beyond that, we used another number place on the left side of it for counting groups of 100. And when those places were maxed out, we added a place for counting by groups of 1,000, and then by groups of 10,000, and so on. See the pattern? Each time we added a new number place, it was located to the left of the previous one. And each time, it represented groups that were 10 times larger than the previous group. Since the amounts that our number places represent get bigger and bigger as we go to the left, it makes sense that number places for counting smaller amounts, like parts of something that are less than 1, will need to go on the right side of the ones place. That's where the decimal places are found. And, just like the whole number places can go on forever to the left, counting bigger and bigger groups, the decimal number places can go on forever to the right, counting smaller and smaller parts, or fractions. But if number places go on forever in either direction, then how do we know which place is which? I mean, if they all look the same, or worse, if they're invisible, then how do we know which digit goes in which place? Ah, that's an excellent question. We do have a problem now that number places can extend in both directions. Before, when we had only whole number places that extended in just one direction, to the left, we knew that the place that was furthest to the right was always the ones place. But now, we know that number places can extend in both directions, so we need a new way to tell which place is which. What we need is a point of reference.
All right. So let's continue on with our lesson now that we have a better understanding of decimal place value. Decimal place value. So just to reiterate what we saw in the video, what he was explaining was that numbers can exceed in both directions, to the right and to the left, but they all have different meanings. So with this chart here, this decimal place value chart, here is our decimal, and to the right, instead of it being ones, it is now called the tenths. Then we have the hundredths, the thousandths, the 10,000ths, the 100,000ths, and millions. And then to the left of the decimal, we have ones, tens, hundreds, and so forth. So here is the same chart, but it just explains more numbers to the left, so as we discussed in our place value lesson. So here is our decimal, and to the left we have the ones, tens, hundreds, thousands, 10,000s, 100,000s, and millions. And to the right, just as we went over in the previous slide, we have the tenths, the hundreds, and the thousands. So now that we have had a chance to watch the video and go over the chart, I think it's time for us to get a little practice in. So what you're going to do with this worksheet is at the top we have these numbers. We have here's our decimal point. We have numbers to the left and we have numbers to the right. So on these lines here, you're going to write the place value of each digit, which is just what we described in the previous slide. So I want you to tell me what each place value is here. And down below, you're going to do the same thing, except you're going to write it out yourself with these numbers that are located here. So you're going to give the right form of each number using the proper place value. So you guys are going to have a few minutes to do that, and then we're going to discuss the answers. So now that you guys have had a chance to go over the worksheet, we're going to go over the answers. So here's our decimal point, and to the right of the decimal, you should have labeled tenths, hundredths, thousandths, and 10,000ths. And to the left, where number 1, 3, and 4 are, this is the ones place, this is the tens place, and this is the hundreds. So here, you guys should have gotten the answer 16 and 548 thousandths with a TH at the end. And let's skip to the last one here. You should have gotten 6 and 3,211 10,000ths. So we're going to get some more practice with this. Don't be discouraged if you're still having a hard time. We're just getting started. But yes, it is important for us to know where these numbers lie and what they mean to the right and to the left, because they can go on and on.